The space economy will not only generate untold wealth, but it will also make Earth's environment greener. In today's video, we will look at why and how asteroid mining could save the Earth. How is asteroid mining possible? And why could asteroid mining save the Earth? According to Neil Degrasse Tyson, the first trillionaire will be the person who mines asteroids for resources. But there's more to this than just getting rich. Taking resource extraction into space could relieve pressure on our own planet's environment, and it could even be the key to us reaching new planets or solar systems. However, it's not all easy money out there among the stars. It's a logistical nightmare to say the least. So how do we make it work? Is it really worth it? And once we've mined our space resources, what do we do with them? Welcome to Future. Make sure to subscribe to our channel to get updated with everything on future technology, Elon Musk, or SpaceX. Let's jump in. Asteroids will be the first place we explore when looking for mining locations in space. They are our solar system's closest and most valuable resource. The surface of the Moon or Mars will just not be dense enough with the good stuff to be viable. Simply constructing and manufacturing a mining gear that can go into space will be prohibitively expensive. It will almost certainly be the most expensive enterprise in human history. The obvious flaw in this model is that once we have a limitless supply of minerals like nickel, it ceases to be uncommon and, by extension, valuable. That's a lot of money, but is it worth it to develop an entire space mining industry to go after it? What about Ryugu? This is an asteroid that the Japanese Space Agency has been examining, and it's currently thought to contain a variety of valuable commodities such as nickel, iron, cobalt, water, nitrogen, and hydrogen. The asteroid's value is estimated to be over $80 billion, and it is accessible enough that specialists predict that after the cost of a mining operation, the asteroid may yield a profit of around $30 billion. So all of the gold, cobalt, nickel, iron, platinum, and other rare but extremely valuable elements in the Earth's crust came from asteroids that impacted after the planet was formed. We've already been able to scout a few asteroids in our neighborhood that might make for good mining candidates. For example, there's Bennu, which is the asteroid in the solar system that is most likely to smash into the Earth and kill us all sometime in the next 100 years. Or in other words, the value of Bennu is believed to be over $700 million. It's more complicated than that, since while the supply would be plentiful, access to it would be limited because it would involve flying through space to collect and return it, plus the constraints of a spaceship's carrying capacity. The SpaceX Starship, which has a cargo capacity of 100 metric tons, is the closest thing we have to a practical interplanetary cargo vehicle so far. In the year 2020, Earth's yearly nickel production was 2.5 million metric tons, which equates to 25,000 Starship cargoes of pure nickel each year for asteroid mining to even match Earth mining, which would need 70 Starship launches per day on average, every day on a trip that would take 2 to 3 years to complete. So that's not exactly a scenario we'd consider feasible. At the very least, place probes on asteroids, which has previously been done by the Japanese Space Agency. The Hayabusa, or Peregrine Falcon mission, was launched in 2003 to examine near-Earth asteroids, and Hayabusa 1 landed on the Itokawa asteroid in 2005. This is a small asteroid with a diameter of less than 1 kilometer, and the probe landed on it and collected samples in the form of tiny grains of asteroidal material, which were returned to Earth aboard the spacecraft on June 13, 2010. This wasn't the first probe to land on an asteroid, but it was the first to land, collect samples, and then return. The Hayabusa 2 spacecraft launched in 2014 on a journey to the asteroid Ryugu. The probe studied the asteroid, collected samples, and returned them to Earth in December 2020, when the payload from Hayabusa 2 arrived. So, can we just turn these small-scale probe tests into full-fledged resource extraction? The fact that a probe is so small and light makes it relatively straightforward to transport it to an asteroid and make contact isn't the only reason. We rely on the atmosphere to handle the majority of the deacceleration energy. But asteroids don't have atmospheres and don't have gravity, which is another issue. The mind may have enough mass for microgravity, but it's thought to be just. The Earth, for comparison, has a gravity of roughly 9.8 meters per second squared, depending on whatever section of the planet you measure from, and that is the largest and densest asteroid. On Earth, the simplest way to mine rocks is to drill a long hole, place explosives in it, and then set off a huge explosion that breaks up the rock, which we then extract the rubble from. However, if we did that on an asteroid, all the rubble would just shoot straight out into space, and any rock that we break free from the mass of the asteroid would not stick around. So that's just logistical craziness to try and figure out we'd need some. Let's say we put a mining rig on an asteroid, extract resources without letting them float away, and begin delivering them back to Earth right now. How are we going to get them down to the surface so we can use them? Because the SpaceX Starship is the closest thing to a working space vehicle, it can lift off with 100 metric tons of cargo thanks to the most powerful first-stage rocket booster ever created. And SpaceX appears to be confident that the second-stage Starship can land on the Moon and Mars with that much weight in it. The gravity on Mars is about 1/3 that of Earth, so that makes sense, but it seems a little more unlikely that a diver can land on the Moon and Mars with that much weight in it. So if a spaceship full of rocks can't land, how are we going to bring them down here? I'm not sure if anyone knows, but it's fun to imagine that we could build a massive space capsule that can land in the ocean and float there, similar to the one that brings people down to Earth. It could have an epic parachute the size of New York City, and it could land in the ocean and float there. There's definitely a limit to how much weight we can throw into the water, but anything large enough to be truly beneficial would almost certainly result in a massive tsunami that would destroy everything. As a result, that's probably not a good idea. How about a space elevator, similar to a grain elevator, but working in the opposite direction and obviously large enough to reach from the Earth's surface all the way into orbit? We suppose it would eventually collapse over due to its height, unless the foundation was the size of Mexico. We're convinced there's plenty of water inside asteroids in the form of ice water, but ice water is quite heavy, making it difficult to transport from Earth to space. Water is not only necessary to drink, but it is also required to rehydrate astronaut space food. When considering concepts for a radiation shield that could be employed in deep space travel, water is an excellent insulator even for usage within Earth's orbit and for journeys to the Moon. It's definitely more cost-effective to source water in space than it is to try to launch it in a rocket. Just getting the equivalent of one bottle of water into orbit can cost up to $43,000. Between Mars and Jupiter, there is a dwarf planet called Ceres that is mixed in with the asteroid belt. Hubble Space Telescope imaging indicates that it contains more water than the planet itself. Water mining on asteroids isn't exactly as exciting as digging up space rocks, but it's honestly probably the most practical thing we can do out there, unless, of course, we want to start building spaceships in space, which is exactly what we want to do. But as a side note, there's a process called optical mining, where we could concentrate heat from the sun to essentially bake the water vapor out of the rocks and collect it. But water mining on asteroids isn't exactly as exciting as digging up space. What are your thoughts on space mining? Is it a hoax or a path to endless wealth? And if so, how do we get it down to Earth? Share your thoughts in the comments box below. That's all for now. Don't forget to subscribe to our channel to get updated with everything on future technology, Elon Musk, or SpaceX. Thank you for watching.